Hello, and today we'll talk about gate-induced drain leakage and series resistance in MOSFET, and finally a MOSFET breakdown. First of all, let's start with the gate-induced drain leakage, which is a drain leakage caused by gate and the substrate. As you can see in this image band diagram, those electrons, those carriers can tunnel through easily, which causes the unwanted, unnecessary flow of current on on the parts where it is under the threshold voltage, which will lead to a poor subthreshold swing and overall a poor performance of the transistor. Moving on to a series resistance. Uh, First, I'll talk about the source drain series resistance. As we learned in the previous chapters, the total resistance really matters because it is tied down to a overall frequency of the MOSFET, hence which is the total number, which is the total determines the total speed of the operations during transistors, and it is really important to take care of a thing as known as the contact issue, which is a resistance between the metal part, which is the metal part, and sub the semiconductor drain and source part. Um, the final thing I'll talk about today is the MOSFET breakdown, and this breakdown is really similar to one we know in the junction in the PN junction, known as the avalanche effect, and which is literally the same thing. If you look at this picture, at this figure, it is much easier to understand. This, which is this boundaries between both two junctions, the PN junctions, uh, as it gets reverse bias, the distances between those two potential energies will be short, and the tunneling will be short, and tunneling will occur. But what really matters is the avalanche effect. As these electric fields gets more intense, a electron hole pair generation will occur in these energy bands and occurring avalanche effects, which will result in this kind of graph, also resulting in a poor situation of the diode or of the MOSFET. Thank you for listening. This is Young Kim of Semiconductor class.